Hi, this is Colton Beavers. We're going over our polarimetry and polarizing light. This is for Lab 2. We are going over the phenomenon of why polarizing light will be affected by chirality and the rotational forces of some molecules. So for the first example, this is an example by the organic chemistry professor, where he says that light, our light source, in this case we had our candle, it emits light in all different directions, but we use a polarizer that only allows the light to pass through one specific direction. So this initial polarizer allows the light to pass in any directions. In this case, we have it going through our medium, which we have, in any case, it doesn't matter, it's dextrose, fructose, and L-alanine. And inside the L-alanine, or any of the solutions that we had, the light will bend due to the chirality of the molecules. Here I have, this is dextrose, based on some of the forces, or is that the right word? Regardless, the chirality is going to help push the molecule to the right. It's in the R direction. We can look based on like this molecule, we can tell that we have our hydrogen in the back down here, and then we have our oxygen, which will be our 1, and then we need to find out which is 2, so we'll just go either 1, 2, this will be our 2, so no, I don't think so. We have hydrogen, we have hydrogen, we have carbon, carbon, hydrogen, hydrogen, oxygen, oxygen. Oh, let's see. 1, 2. Let's see. Okay, since we'll start here as 1, and then we have our 4 in the back, we're going to see that it's going to go to the longer chain. Since these are both equal, we're going to have our starting carbon, we have carbon, carbon, and then it's going to match with hydrogen, hydrogen, and then we're going to match with oxygen, oxygen, and then we're going to have the longer chain down here. So that means we're going to go 1, 2, 3, 4 down here. So that means we're going to rotate in a clockwise direction. Thus we have an R. This will be named at R. I don't remember which number this is, to be honest, but regardless, it'll go R, and so that will affect the light going through this molecule, and it'll slightly affect it and moving it to the right based on the chirality. And then to observe this phenomenon, we have our other polarizer here. So this is our initial. We've got the light coming through it, going through our molecule, and then going through our molecule, and then we observe the dark point, but there's no light going to be passing through, right? So in our lab experiment that we had, we actually had a positive degree of rotation for the light to pass through. But here, I mean, obviously there's no light and there's no medium that we're going to go through. But we use the second polarizer to tell how much of the solution that it went through. let's see. That should explain why the phenomenon occurs. Different compounds are affected by the R and S factors. We know that these, we can observe that these molecules are optically active by a degree of rotation inside, or by the polarizing sheets, but we also know they can be optically active, knowing if a molecule is chiral or not. Chiral molecules are active and achiral molecules are inactive or optically inactive. Concentration plays a role in the results, because concentration, the molecules will bend each individual light. Purity, purity effects, because we have two different versions. We can have the cis, or well, we have multiple different versions of this molecule of dextrose, but each one can have a different optical rotation to it, and so the more of one specific molecule that we have will have more optical rotation to there. So we had our theoretical of dextrose, which was X, and then we had something in the middle, closer to 0, because we had an unpure dextrose form. For this phenomenon to occur, we need polarized light, so we can see this in like sunglasses and like gas station screens, when sometimes we can't see them with that's polarity. For us not to be able to see the different directional change in polarity, we have to have a chiral molecule bending and changing the direction of light between two different polar surfaces. Okay, that's long-winded, I'm sorry.